Hi, AbGcoder. We're going to look at a really cool structure here called the binary search tree. And the reason we're doing it actually is we actually lately have built, right, a linked list and an arrayed list as well. They were good. They're strong, and we're going to use those a lot. They're common objects, but they don't search very well, right? They do a linear search. So if we have a trillion elements, we may have to search through all trillion of those, scan through all trillion to find a match. That's not good. In an average case, half a trillion, right? That's not very efficient. So how can we do a better job there, or what's a better, I guess, idea? So a search tree actually is the search tree is basically like this. There's the smaller values to the left and larger to the right. And I'll go through this quick because it's all here for you. So if we search for 40, that's less than 50. We're going to go left. We're going to navigate then to the right there, and we're going to find it right there. Just a couple comparisons, and we've got it, instead of scanning through every single element like we'd have to in a list. So that's how that is. I'm just going to point out a couple things, try to keep this short for you. The challenge, okay. One thing is balance is really important in the tree, but tip is to not worry about balance at first. Get it working first right, and then worry about balance later. So that's just a quick tip. These labs, there's a couple labs provided for you. I would play around with those. I like to always just get a feel for what's kind of happening with the objects. We're going to use a binary function like we a lot of times do, by function. So here's how that works, and we can play with that. Right now it's going to print out two numbers. It should be 15. Let's change that to a multiply, and that should be 50. That is. Same with comparator here. It kind of just get a feel how comparator works. I like to do that. And then the tree itself, I like to make a little lab for that. Here's really a fundamental little experiment for a tree. We're told how to construct a tree in this challenge, so that's kind of nice. But we need a comparator, and here we're searching by employee name. I should say sorting by employee name. And we're also then, of course, searching by employee name as well. So we're using these functions for that. Then I'm going to add 3 elements, make sure it prints out okay. Again, this is a function here, and then see if we can find a match. And if we run that, we're expecting to print out, it's actually reverse order because we have a -1. Where is that here now? A minus there and a minus there. So it's reverse order. So this is how it's printing, and then we find the match right there. We can see we found it. Okay. So these are just a couple labs that will allow you to play around and such like that. I will also note that the interface, as always, gives us most of the information. It gives us all the methods we need to code, right? But it also gives us the how we need to code them. You know, a little bit of comment there to drive that. Duplicates are allowed, it's telling us, and it's telling us what to do if there's a tie, what to do if there is a duplicate. Looks like it's going to go to the right, right? It's only going to go left if it's less, otherwise it goes to the right. So that is that. Like I said, I want to try to keep it short. So what else do we have? I think that is really about it. The examples are, there's test available for you. There's labs available. It's really a matter of playing around. And again, I'll just say it one more time. I would keep it simple at first, you know, really just, you know, fundamentally, what we're doing with the tree here, right, is we are constructing the tree. That's always kind of half the battle sometimes, right? Constructing it, then we're adding a few elements into the tree. And I'm just adding 3 because I can see that. We can see that better, right? And it should scale, you know. We want to make sure, but it should scale to 3 million to 3 trillion. Do this visit function and then a search. This is kind of the fundamentals here, and this will weed out a lot of bugs. It does for me anyway. But anyway, I'll keep it short and throw questions on the discussion board. We will talk to you soon.